Our next topic is series and parallel circuits. And before we get into the actual circuits and the concepts of series and parallel, we need to say a little bit about schematic diagrams. Everything that electricians do is represented, or everything that they use is represented with a little symbol. And I've been drawing pictures of a simple circuit made of a battery and a light bulb. And I'll show you how we would represent this circuit schematically. So let's draw the light bulb and some wires. Okay, an electrician, if you were making an electrical diagram, he would not draw a picture like the one I just drew. There are three things in this picture. There's the battery, the voltage source, there's the wires, and there's the bulb, and he would draw the picture like this. That little set of lines represents the battery, and the wires would always be drawn with straight lines at right angles, and the bulb would be drawn like this. That little loop inside the bulb represents the filament, and then the wire coming down to the other side would look like that. And for each thing, like a bulb, for example, you see that symbol, and the battery, for example, you see that symbol. Each thing that you can put in a circuit, and there are lots of things besides batteries and bulbs, but each thing has its own symbol. And you also might have a switch in here. Let me put a little gap in the wire and put in a switch. Something like that. That might correspond to a little switch here in the wire. You could have a little device here with a little switch that you could flip back and forth to allow the current to flow or not. But again, you wouldn't draw an actual picture of the switch. You would draw this symbol, which represents any switch. Now, another thing that you commonly see is not just a light bulb in a circuit, but you see a resistor, which is represented by this zigzag line. So this circuit has a voltage source V and a resistor R. And the resistor could be anything. It could be a toaster. It could even be an electric motor. It could be something that has electrical resistance. It could be a heater, or it could just be a resistor, an actual little device that is simply there to limit the current flow. It's actually pretty common to have a bulb and a resistor in combination. So we might have a bulb here and the resistor there, and the resistor keeps too much current from flowing through the bulb so that it doesn't burn out. But again, the point here is that we have all these little symbols for the things in the circuits, and the diagrams are done at right angles like this to keep them neat, because they can get large and complicated. Here's a picture of a circuit diagram for a solar panel regulator, and there are lots of pictures like this that you can find on the web, on the internet. If you want to build something, you can see diagrams of how to do it. And they can get a lot more complicated than this. And in a more advanced physics or electrical engineering class, you would become very familiar with diagrams like this, schematic diagrams. Now let's talk about series and parallel. Fundamentally, there are two ways in which resistors can be connected, or anything. I'm going to be drawing these diagrams with resistors, but you could be connecting resistors, light bulbs, toasters, anything. And there's two ways that they can be connected to a battery or some other voltage source. They can be connected in series, which would look like this. Here's the battery, and I'll draw a wire coming out here, and then here's one resistor, and here's another, and here's another. And the point here is that they're connected all three in a row. So if you imagine the current flow, the charge comes out of the battery, flows around the circuit, it goes through one resistor, then through the next one, and then through the third one. And there's only one path. It's like a one-lane road or a one-lane loop road. There's one way to go. Every electron that comes out of the battery goes around and follows that wire, goes through resistor A, and then resistor B, and then resistor C, and then back to the battery. Now, a parallel circuit is different. In a parallel circuit, the current divides. So I'm going to orient this one a little bit differently. But here's a battery, and then imagine you have a wire coming out here. And then the wire comes over to this point and splits into three paths. So electrons coming out of the wire, they travel around the circuit this way, and then they divide. Some of them go down this branch, some down that branch, and some down the third branch. And you could have on each branch a resistor. and then the electrons flow through those resistors, and then they all join back up. And then the current flows back to the battery. So the electrons all end up coming back and rejoining at this point, and then flowing back to the battery. And the essential aspect of a parallel circuit is that the current divides and flows through multiple paths. It doesn't have to be 3. It could be 2 paths or 4 or 100. The point is, in a series circuit, the current goes through one and then the other, all of them in a row. And in a parallel circuit, the current divides. Now, one thing to note is that the actual geometrical layout of the resistors in your little circuit project isn't the determining factor in whether or not the resistors are in series or parallel. The determining factor is whether the current divides or not. So in this case, for example, I have a resistor here, and imagine the electrons flowing through it, and then they come down and flow through this resistor, and then they flow through this one, and then they flow back to the battery. Look at the actual physical layout on the screen here. These 3 resistors are literally parallel to each other. Those wires are parallel. They form parallel lines. But this is not a parallel circuit. This is a series circuit. And the reason is because the electrons come out of the battery, they flow through one resistor, and then the next one, and then the next one. All 3 in a row. Electrically, this is no different from the one we drew earlier, like this. The electrons flow through one resistor, then another, and then another. The electrons don't really know or care how the wires bend or how the circuit is shaped. What does matter is whether the current divides or not. And if it divides into multiple paths, then it's a parallel circuit. If the electrons go through one and then another, then it's a series circuit. Okay, a couple more comments about series and parallel circuits. I've drawn 2 pictures here of light bulbs connected to a battery, one in which they're connected in series and one in which they're connected in parallel. And you can see in the series circuit, electric current flows through all 3 bulbs in a row, and in the parallel circuit it has to divide and goes through 3 different branches. And that's the fundamental difference in the series and parallel circuits. In the series circuit, current could be flowing through all of these bulbs, so they could all be sitting here shining. But if one bulb burns out, that essentially breaks the circuit. And it doesn't matter which bulb. Suppose this bulb in the middle right here burned out. So I'm going to scratch out the filament, like the filament just burned out. In that case, the bulb will go out, and so will the other 2. Because if this filament is dead, if this filament in the middle bulb is broken, then that's part of the path through which the electricity flows. And if you break that path, then none of the electricity flows. And when the current stops flowing, the bulbs don't light. In the parallel circuit, these 3 bulbs could be sitting here glowing. All 3 of them are lit. And if one of them burns out, suppose the one in the middle here burns out. So I'll just scratch out the filament, and it could break or crack. The filament is no longer conducting electricity. That means electrons no longer flow down that middle branch. And so that bulb goes out. But the other 2 bulbs remain lit. You can see that electrons can still form a complete circuit right there, and they can still travel through the 3rd bulb like that, right there. It's only that one branch that's compromised by the breaking of that bulb. The other 2 will continue to light. And there's another effect that you should understand with series and parallel circuits, and that's the effect of adding more bulbs. If I start adding more bulbs in the series circuit here, remember that each bulb has resistance, so adding more bulbs causes a greater total resistance, and that's going to cause less current flow, and each bulb will burn less brightly. But because there's less current flow, adding more bulbs causes less current to come out of the battery, and the battery would end up lasting a little bit longer. And that should make sense too. If the bulbs burn less brightly, the battery will last a little bit longer. So if they're in series, adding more bulbs in series increases the resistance and decreases the current. In parallel, the opposite thing is the case. If you add more bulbs in parallel, suppose I come over here and add another light bulb over here. I've added an additional path through which current can flow. And this is like adding more lanes on the highway. There's now an additional path that the electrons can take, and the result is more traffic. You add more lanes in the road, you get more traffic there. So adding an additional light bulb in parallel, or more light bulbs in parallel, will decrease the overall resistance because you're adding more paths for current to flow. All the light bulbs will continue to burn just as brightly. What happens is the decrease in overall resistance results in an increase in current flow. So you can take a little battery, a little flashlight battery, and you can hook up 10 or 20 bulbs to it in parallel, and they'll all glow very brightly. But what happens is your battery will drain more quickly because you're literally drawing more current out of the battery. If you hook up 10 or 20 little flashlight batteries, little flashlight light bulbs to a battery in series, there's going to be too much resistance. You won't see any glow at all. But if you hook them up in parallel, they'll all glow just as bright as normal, but you'll have decreased resistance and increased current flow.